In this video tutorial, I will show how to evaluate machine learning model. What do I mean by that? What is the definition of success? Is a machine learning model accurate at 95% good enough? Did we solve the business problem using machine learning? How to do that? In this section, I will show how to compare predicted labels to the truth labels, show the evaluation metrics for different types of machine learning models. This video tutorial can be used as a separate one or as a bigger picture for the machine learning workflow, and in this case it will be fifth point, evaluate ML model. If you haven't seen my previous video tutorials, I highly recommend to do that. The environment setup, Jupyter Notebook, data load and analyze, model choose ML model, split data features labels, train model predict. Before we start with the evaluation process, we need to answer a few questions. How can we know if the model performed well? How can we measure the performance? How can we tune the model to perform better? Before we can go to the fifth point, which is evaluate the model, we need to have the previous steps. I've prepared the code to speed up the coding. This is just a quick recap of the previous video tutorials. So what we need to do? We need to load the data. We need to split the data into features and labels. We need to split the data into training set and test set. We need to create machine learning model. We need to train the model. And we need to make predictions using the machine learning model. Before we can start with the model evaluation, let's see what kind of evaluation metrics do we have. So now I will describe the regression metrics, and we have mean absolute error, which is average absolute difference between predicted and actual values. So what does it mean? The predicted and actual values. In that case, the predicted values are those that we have when we run the predict method, ypreds. And the actual values are those we get when we use this train test split, and this is the y train. So what this mean absolute error do? It finds average absolute difference between these values. The mean squared error also works on the predicted and actual values, so the predicted ones ypreds and the actual y train, and it finds the average squared difference between those values. So what does this r squared mean? The proportion of variance in the dependent variables explained by the independent variables. So in simple words, the independent variables are features and the dependent variable is a label. So going back into this example, this is the independent variables x and the dependent variable. So the r squared is finding the proportion of variance between those variables. So let's jump to the code and see how it works. I will put it more down and start the evaluation of the model. Like always, all we need to do is import some modules from scikit-learn metrics import, and from the above mean absolute error, mean squared error, and R2 score, and that's it. Now we need to use that functions mean squared absolute error, and we can go in here shift tab, and as you can see y true, y pred. In our case y true is y test and y preds, and the same for the other mean squared error y test y preds and r to score, Shift Tab, the same Y true, Y pred, in here Y test, Y pred. To speed up the coding, I've assigned each of these metrics into variables and prepared print statements. So now I run Shift Enter and we can see the metrics of this model. At the beginning, these outputs won't say much and we even don't know if it's correct or not to have these outputs. But when we step into the experiments, when we change the parameters of the model and we do some fine tuning, we will see if the values will change as well. But the fine tuning and experimenting is out of this scope. I've added a third column with the description for each matrix and the mean absolute error. This tells us on average how far our predictions are from the actual values. Lower is better. For the mean squared error, similar to MAE, but it gives more weight to bigger mistakes. It squares the errors before averaging them. And the R-squared, this shows how well our predictions match the actual values. A score of 1 means perfect predictions, while 0 means the model is no better than guessing the average. So now let's talk about the evaluation metrics for classification. So in here we have accuracy, precision, recall, F1 score, and the confusion metrics. So the accuracy is proportion of correct predictions. So the precision is true positives divided by true positives plus false positives, avoiding false positives. Recall is true positives divided by true positives plus false negatives, finding all true cases. F1 score, harmonic mean of precision and recall. And the confusion matrix, summary of the true positives, true negatives, false positive, false negative. So what do I mean by true positives? Correctly predicted positive cases. True negatives, correctly predicted negative cases. So false positives, incorrectly predicted positive cases. Type 1 error. False negatives, incorrectly predicted negative cases. Type 2 error. So much words, but the picture is worth than 1,000 words. So in here, type 1 error, false positives. The man, you are impregnant. Type 2 error, false negatives. Woman, impregnant, but the doctor say you are not impregnant. Enough theory on that topic. Now let's jump into the classification models. Now we have to change some of this code because here we were using linear regression. Now I want to use logistic regression for classification problem. Like always, we need a perfect data. You can find the perfect data in one of my blog posts. How do I work with the data for machine learning? And there is a link to my GitHub repository. And there is a file heart disease Kaggle CSV. I've downloaded it and will be using it. So in here, I will change this into heart disease Kaggle, Shift Enter to run it. Now we don't have the sell price column. We have the target column. So I will change it to target in here as well. Shift Enter to run it. Shift Enter to split the data. And now we have to change the machine learning model. Instead of linear regression, I will use logistic regression and Shift Enter to run it. I know it's a little bit confusing that I'm using logistic regression to show the classification model, but that's the naming of it. So now let's train the model, run the fit, and now let's predict the values. And we cannot use previous metrics, we have to choose different one. Now I need this matrix, so I will add below the import from scikit-learn matrix import and accuracy score, precision score, recall score, F1 score, and confusion matrix. Shift enter to run it. So like in the previous example, I've prepared print statements to see the results. And we have it. So what we have in here, accuracy 85%, proportion of correct prediction, pretty good. Precision 85% as well, avoiding false positives. 88% recall, finding all true cases. That's good. And the confusion matrix. So how to read this confusion matrix? Let we see. So we have 74 true negative, 70 false positive. And it means that model correctly predicted 0 when the actual value was 0. False positive model incorrectly predicted 1 when the actual was 0. Type 1 error. And so on. So that's it for today. Happy coding, happy learning.